Hello everybody and welcome back to another math learning video. Today I brought you guys this geometry problem here where we're given this figure that has three identical circles inside, and surrounding these circles kind of as a perimeter we have this huge red line that spans the perimeter of the three circles on the outside. And what we are tasked with doing is to find the length of the red line here. So how long does this go around for? And we are given that the diameter of one of this circle is equal to 2. And since all of these circles are identical, that means each circle has the diameter of 2. So let's go ahead and get started and find the length of the red line. So if you pay attention and look at the red line, you will notice that it has kind of different sections in it. So the first section kind of goes like this, where it's just a straight line. And you can see that this straight line in between two circles, it appears 3 times throughout this whole red line. So it appears here, as you can see, it's right between two circles, this straight line. And then here, also straight line between two circles. And here also. So since the circles are all identical to one another, that means that these three green segments are also identical length to one another. So therefore, in finding the length of our red line, we know that 3 times the length of the green segment shows up. So I'm going to go ahead and write that down. So the total length, which I'll note as L, is equal to 3 times the green segment. Of course, we don't know how long that is yet, so we're going to have to figure that out. But obviously, the total length is not only equal to 3 times the green, because also, so you can see we have kind of this curved part here, where it curves around like this. And this also appears 3 times. So here I labeled it as orange. So this also appears 3 times in our total red line figure. And these are also identical to one another. Each orange is identical to one another since it is kind of the outside curvature of the circle. And each circle is the equal length, equal size. So our length will be 3 times the green segment plus 3 times the orange segment. And as you can see, this already covers the whole length of our red line, our perimeter. So now all we need to do is find the length of these values. So for the green line, for its length, we can see that it kind of spans from the middle point of one circle towards the middle point of another circle. So this is kind of the length of the line, like this. So since we know that this is the length of the line, this green part in one circle is the radius, right? The radius of the circle, because the radius is from the middle point of the circle to any outer part. And so it's the radius of one circle plus the radius of another circle. So what is the radius? Well, the radius, since it will be and these circles are the same, right? So their radius will be the same. So the radius, so our value that we're looking for will be 2 times the radius. That'll be the value of the green. And 2 times radius is automatically the definition of what the diameter is. Diameter is always of a circle is always 2 times the radius. So since we know that our radius, or our diameter, excuse me, is 2, we know that the 2 times the radius is also equal to 2, which means our radius is 1. But this green line that we drew, so this green segment is equal to 2, its length. So if the length of the green segment is equal to 2, we can plug that into our equation here. So for our length of our total red value, we're going to be multiplying 3 times 2 for the green part. And now it's left to find the orange part. How long is the orange part for this circle? So how do we figure this out? Well, so this orange part completely is around the circle, right? But we still, how does that help us find how long it is? Well, since all of the orange part is on the circle, we need to see how much of how much of the circle, of the circumference of the circle. Remember, circumference is the perimeter of a circle. So how much of the circumference does the orange part take up? And we can do this by using angles. So if we look at one circle, because all circles are identical, we see that, so we already know that this part of the circle here, this, since it goes straight down, it's perpendicular to the straight line here, to the green line. This blue is perpendicular to the green, so we have already 90 degrees taken up here. And now if we draw a triangle connecting all of the middle points of the circles together, we will have an equilateral triangle. An equilateral triangle, it has 100, so any triangle has 180 degrees total, right? But an equilateral triangle, where all the side lengths are the same, all the angles are going to be the same here. So 180 total degrees divided by 3 angles is going to be 60 angles for 60 degrees, excuse me, for every angle of the triangle, including the angle that is inside the triangle that inside the circle that we are dissecting here. So we know that this is equal to 60 degrees, this part of this circle. And now if we were to draw a rectangle in our between these two circles like this, with the edge coming at the edge of the orange part, this would make a rectangle, right? And for every rectangle, every angle is a right angle, so every angle is 90 degrees. So this angle is also 90 degrees. So now we have figured out the total angles of these 3 parts, and what is being left out is the angle of our orange that actually we want. So the angles that are not made up of the orange are 180 degrees, are 90 degrees, plus 90 degrees, plus 60 degrees, right? 90, 90 and 60 here, which is equal to 90 plus 90 is 180, plus 60 is equal to 240. So since 240 degrees are not in our orange segment, a circle has a total of 360 degrees, right? And 240 degrees are not in our orange segment, so that means our orange segment is totally 120 degrees of this circle, right? Which is also 1/3 of the circle, since 120 is 1/3 of 160. So how will this help us? Well, the percentage of the angles also, or the size of the angle in corresponds directly to the size, to the line segment size, to the total circumference of the circle. So first we need to figure out the circumference of the circle, which is which is given by the equation 2 pi r. So we know that we already found r is equal to 1. But we also need to keep in mind that we are not looking for the whole circle, its circumference, but the 120 degrees of the circle. So we're going to do the 120 degrees over 360, which, as I mentioned before, simplified is equal to 1/3. So our circumference will be 2 pi times 1 is, it will just be the same thing, so you can just not worry about that, times 1/3. So our circumference will be 2/3 pi. So now let's go back to our original equation where we have 3 times 2/3 pi. And let me make some space here real quick. We can simply simplify this equation now. We have that L is equal to 3 times 2, which is 6, plus 3 times 2/3 pi, which will 3 times 2 is 6/3 pi. To give us our final answer, simplified, of 6 plus 2 pi, or I'll write 2 pi plus 6. So this is the total length of the red line, although we can't see the red line anymore since it's been covered up by the other colors of the segments, but this is our total length of it, the perimeter of this shape here. So I'll write units just to be safe. And that is it for today. So thank you guys for watching this video. I hope you guys enjoyed it, and see you guys next time. Bye.